All right, let's dive right into the incredible world of game AI. We're going to look at some of the really cool techniques pulled straight from the book AI Techniques for Game Programming that developers use to make game characters, well, smart. We're talking about AI that can learn, adapt, and maybe, just maybe, outsmart you. You know the feeling, right? You're deep in a game and you see an enemy just running into a wall over and over again. Or you figure out that perfect little spot where the boss gets stuck in a loop doing the same 3 attacks. It works, sure, but it's not exactly what you'd call smart, is it? So this really gets to the heart of it. On one side, you've got your standard scripted AI. It follows a strict set of rules, kind of like a robot on an assembly line. It's predictable. But on the other side, you have a learning AI. This is the goal. Something that can adapt, that can surprise you, and that can evolve as you play. For game developers, making that leap from the left side to the right side, that's been the holy grail for a long, long time. Right, let's talk about this predictable opponent problem. And hey, let's be clear, traditional AI gave us some absolute legends. I mean, think about Age of Empires or Quake. The AI in those games works. It absolutely does. But even back then, developers were already thinking, what's next? They wanted to build a new generation of games with opponents that felt less like predictable machines and more, well, more like they were actually thinking. I love this quote from the book. What one fool can do, another can. It's such a great way to think about this stuff. The whole idea is that these big, complex topics like AI, they don't have to be scary or intimidating. You can break them down into simple pieces. And that's exactly what we're going to do right now. We're going to make this stuff easy to grasp. Okay, so we've laid out the problem. Now for the fun part, the solutions. And the first one is just brilliant because it borrows from the most powerful learning system on the planet, evolution itself. We're talking about something called genetic algorithms. So what is a genetic algorithm? Well, think of it like this. Instead of trying to perfectly program a solution from scratch, you basically create a digital version of survival of the fittest. You set up an environment where a whole bunch of potential solutions compete, and only the best ones get to survive, reproduce, and pass their digital DNA on to the next generation. It's problem-solving nature's way. It all boils down to this really cool 4-step loop. So here's how it works. First, you just create a bunch of totally random solutions. Think of them as the first generation of creatures. Step 2, you test every single one of them to see how well they do the job. That's their fitness score. Then, step 3, you pick the winners. The ones with the best scores get to be the parents. And finally, step 4, you let them breed. You mix and match their code, that's called crossover, and you throw in a few random changes, mutations, to create a brand new generation. And you just repeat this over and over. And with every single loop, the whole population gets just a little bit smarter. Okay, let's make this real. A perfect example and one that's super useful in games is the famous traveling salesman problem. The question is simple. What's the shortest possible path to visit a bunch of cities and get back home? Now, imagine this isn't a salesman, but an AI unit in a strategy game that needs to collect resources from 5 different points on the map. What's the fastest route? That's a puzzle that's tailor-made for a genetic algorithm. So when you first start at Generation 1, things are a complete mess. The computer just generates a ton of completely random routes. They're chaotic, they cross over each other, they're all terrible. Not a single good solution in the bunch. But now let's jump ahead. We're at Generation 100. After running that evolutionary loop a bunch of times, something incredible starts to happen. All those terrible routes, they've died off. The best ones, the shortest paths, have survived and created the next generation. And you can already see it. The paths are getting way more organized, way more efficient. Now look at this. By the time we hit Generation 1000, the algorithm has found a solution that is incredibly efficient. And this is what's so powerful. Nobody told the computer what the best path was. Nobody programmed it in. The system discovered it all by itself through pure trial and error. It literally evolved the perfect answer. All right, that was awesome, right? But that's just one way to do it. Solution number 2 takes its inspiration from nature in a totally different way. So if genetic algorithms are like large-scale evolution, our next topic, neural networks, is all about mimicking the thing that's doing the thinking, the brain itself. Could a machine think? The answer is trivially yes. I mean, that really cuts to the chase, doesn't it? This is exactly what developers are aiming for with neural networks. They want to build a kind of artificial brain that can see what's happening in the game, process that information, and then make a smart decision. It's all about perception and reaction. When you hear a neural network, it sounds incredibly complicated. But a single artificial neuron? It's actually super simple. Look, all it does is take in some information, the inputs. Maybe it sees an enemy, or maybe it doesn't hear a sound. Each of those inputs gets multiplied by a weight, which is just a fancy word for how important that piece of info is. Then it just adds it all up. If the final number is high enough, the neuron fires, and an action happens. That's it. It's just basic math. But the magic happens when you connect thousands or millions of these simple little calculators together. So check out this brainy aliens example from the book. You've got an alien ship controlled by a neural network. So what are its eyes? What does it see? Well, its inputs are pretty simple. It knows where the player's gun is, and it knows where the 3 closest bullets are. That's its entire view of the world. And based on just that information, where the gun and bullets are, the network makes a decision. It picks an output. Should it thrust left, thrust right, go up, or just drift for a second? The amazing thing is, by training this simple network, you can teach the alien to get really good at dodging your shots and coming after you. It becomes a legitimately clever opponent, all from that simple input-output system. Okay, so this all sounds cool in theory, right? Genetic algorithms, neural networks. But is this stuff actually in the games we play? Oh yeah. Let's look at a couple of big examples you've probably heard of. For sure. Ever play Colin McRae Rally 2.0? The computer-controlled cars that seem to nail every turn? Their brains are actually neural networks that were trained over and over again to find the perfect racing line. And what about the bots in Quake 3? The ones that are notoriously tough? They use genetic algorithms to help them make smart decisions, like whether it's better to grab that armor right now or make a run for the railgun. So yeah, this isn't just theory. It's been powering some of our favorite games for years. So where is all this heading? What does the future of game AI look like with these incredible tools? And here's the most important thing to remember. The goal of all this tech isn't just to make enemies that are impossible to beat. That's not the point. The real goal is to create more dynamic, more surprising, more intelligent virtual worlds. It's about having enemies that feel genuinely cunning, allies that actually feel helpful, and a game world that feels like it's really alive and reacting to everything you do. Which kind of leaves us with one last big question to think about. If we can teach a game AI to learn, to adapt, and to outsmart us inside its own little world, what's that teach us about intelligence itself? When we build these systems, we're not just making better games. In a way, we're building tiny little laboratories to explore what it even means to think. And that is a pretty amazing thought. Thanks for diving into this with me.